Alright, let's take a look at question 8. In question 8, we're going to be looking at how to prove that two triangles are congruent. Okay, so question 8 reads, in the diagram below, segment AC and BD intersect at E. Question, which information is always sufficient to prove that triangle ABE is congruent to triangle CDE? Okay, so I want to show that the two triangles are congruent. Now you got to remember the postulates and theorems to establish congruency. Alright, so there are 4 of them that we're going to be using for this particular problem. Let's go ahead and write it down. So cases for congruency are as follows. So to show that two triangles are congruent, you could use either the SSS postulate, you could use the SAS postulate, you could use the ASA postulate, or you could use the hypotenuse, the HL theorem. Alrighty? Okay, so these are the only cases that you can use to show congruency. Now let's take a look at number 1, 2, 3, 4, and then we're going to apply the conditions given to the pair of triangles and see which one satisfies one of these cases. In option 1, you're told that segment AB is parallel to CD. So let's use the first diagram here on the right for option 1. Alright, so if AB is parallel to CD, that means this line right here is parallel to this line. If you have two parallel lines cut by a transversal, you know that alternate interior angles are congruent. So this angle is congruent to that angle right there, alternate interior angles, and then this angle right here is congruent to this angle right here. We know that these two angles are congruent because they're vertical angles. Ladies and gentlemen, what do we have here? We have angle, angle, angle. Okay, so this is AAA. Is angle, angle, angle sufficient to prove congruency? Look at the list. The answer is no. Let's move on to option 2. Segment AB is congruent to CD, so AB is congruent to CD, and segment BE is congruent to segment DE. Is this sufficient to show congruency? We know that these two angles are vertical angles. That will always be the case in all of them. Okay, these two will always be congruent because they're vertical angles. So that gives us an A. These two sides are congruent. That gives us an S. And then these two sides are congruent. That gives us an S. Okay, so whichever way you want to read it, you can read this as SSA or ASS. Are any of these sufficient to prove congruency? If you look at the list, the answer is no. This is not sufficient to prove congruency. Option 3, E is the midpoint of AC. If E is the midpoint of AC, that means that E is going to be at the center, so it's kind of like a point that bisects this segment. So this side right here, AE will be congruent to EC by definition of midpoint. Alrighty, so since these two sides are congruent, we have side, and then since these two angles are congruent, we have angle. Okay, so in this particular case, we have SA or AS. Are these congruent to prove that these two triangles are congruent? Look at the list. The answer is no. So our correct answer should be option 4 by elimination. But let's prove it, okay? Option 4 says that BD and AC bisect each other. So that tells us that BE is going to be congruent to ED, and AE will be congruent to EC. What do we have? We have sides, a pair of sides that are congruent, AE and EC, two pair of angles that are congruent, A, and then two sides that are congruent, S. SAS. Is this a congruency postulate? Absolutely. SAS is a congruency postulate. So with this diagram right here, if BD bisects AC, We have side angle side, and that is sufficient to prove that triangle ABE is congruent to triangle CDE. Okay, so that is how you prove that two triangles are congruent. Watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for your geometry exam, do give us a thumbs up. Your positive feedback is extremely valuable to us. We'll also like to know what you think about this tutorial, or if you have any questions or comments, just put it in the comment section below and we'll be more than glad to respond. Do not forget to subscribe to our channel for updates to the remainder of this review series. More support resources can be found at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.